Antarctica, the southernmost continent, holds the majority of Earth's ice and a significant portion of its freshwater reserves, covering about 14 million square kilometers, 5.4 million square miles. It is home to an estimated 25,400,000 cubic kilometers, 6,090,000 cubic miles of ice. This immense ice mass accounts for roughly 60% of the planet's freshwater and 90% of all its ice. The implications of this ice melting entirely are profound and far-reaching, affecting global sea levels, climate patterns, ecosystems, and human societies. Sea level changes and geographic impact. If all Antarctic ice melted, it would result in a dramatic rise in global sea levels by approximately 70 meters, 230 feet. This rise would drastically alter the world's coastlines, submerging entire regions and reshaping the geography as we know it. Submerged cities and lost land coastal cities across the globe, including major metropolises like New York, Tokyo, and London, would be completely submerged. The state of Florida would vanish entirely beneath the rising waters, and low-lying countries such as the Netherlands, Bangladesh, and Denmark would lose significant portions of their land. Island nations would be especially vulnerable, facing complete inundation and disappearance. In regions like Australia, the rising sea levels would create a large inland sea, fundamentally transforming the landscape. River estuaries would expand significantly, and the paths of rivers would change as floodplains and riverbanks become submerged. This expansion would create new waterways and affect existing aquatic ecosystems. Population displacement. An estimated 40% of the world's population lives within 100 kilometers, 62 miles, of a coastline. The inundation of coastal areas would force billions of people to relocate to higher ground, creating unprecedented levels of displacement and posing significant challenges for urban planning, infrastructure, and resource management. Changes in ocean chemistry. The melting of Antarctic ice, which primarily consists of fresh water, would significantly alter ocean chemistry. This influx of fresh water would decrease the salinity of the oceans and affect various dissolved chemicals and the pH levels of seawater. Impact on salinity and marine life. A reduction in ocean salinity would have complex effects on marine ecosystems. Some marine organisms, particularly those sensitive to changes in salinity, might struggle to adapt, leading to shifts in species distributions and potentially disrupting food webs. Coral reefs, which rely on specific salinity ranges, could be particularly affected, exacerbating the challenges already posed by ocean acidification and rising temperatures. Effects on oceanic currents and climate. Oceanic currents, driven by gradients in temperature and salinity, play a crucial role in regulating global climate patterns. The influx of fresh water from melting ice would disrupt these currents, potentially altering climate systems such as the Gulf Stream and the thermohaline circulation. Such changes could lead to regional climate shifts, affecting weather patterns, precipitation, and even the distribution of heat across the planet. Isostatic rebound and geological effects. The melting of Antarctic ice would trigger a process known as isostatic rebound, where the Earth's crust, previously compressed by the weight of the ice, begins to rise. The mechanics of isostatic rebound. Antarctica, currently weighed down by its ice mass, would experience uplift similar to a heavily laden ship rising in the water when cargo is removed. This uplift would occur over tens of thousands of years, with an estimated initial rise of about 7.5 centimeters per year for the first 2,000 years, gradually decreasing to about 1 centimeter per year over the subsequent 10,000 years. The total uplift could reach up to 400 meters in some areas. Long-term geological changes. This isostatic rebound would lead to significant geological changes, including the formation of new landforms and the alteration of existing topography. The uplifted land would eventually stabilize, but the process would be accompanied by increased seismic and volcanic activity as the Earth's crust adjusts to the new equilibrium. Temperature effects and habitability. The complete melting of Antarctic ice implies extreme global warming scenarios, with temperatures rising far beyond current projections. Under such conditions, the tropics would become uninhabitable due to extreme heat, forcing populations to migrate toward the poles in search of more temperate climates. This shift would disrupt agriculture and food production, leading to widespread crop failures and threatening food security. Ecosystem collapse and mass extinction. Ecosystems across the globe would face collapse as rising temperatures and altered precipitation patterns create inhospitable conditions for many species. This would likely result in a mass extinction event, with significant losses in biodiversity and the disruption of ecological networks that support human life. Historical context. The last ice-free Antarctica. The Antarctic ice sheet began to form around 35 million years ago, during a period when global temperatures were about 4 degrees Celsius higher than today. Before this ice formation, Antarctica experienced different climatic conditions and ecosystems. The isolation of Antarctica over the South Pole and the development of the circumpolar current, resulting from the drift of South America away from Antarctica, contributed to the continent's cooling and the formation of the ice sheet. This current prevented warm water from reaching Antarctica, allowing the ice to accumulate. During the late Cretaceous period, approximately 90 million years ago, Antarctica was covered with temperate rainforests, similar to those found in present-day New Zealand. These forests thrived in a warmer climate, with high levels of carbon dioxide, 1,120,680 ppm, and long periods of darkness during the polar night. The transformation from a temperate, forested continent to an icy wilderness highlights the dynamic nature of Earth's climate and geological processes. Potential large-scale melting events. Current scientific observations and models suggest that parts of Antarctica, particularly the Thwaites Glacier and the West Antarctic Ice Sheet, WAIS, are vulnerable to significant melting. The Thwaites Glacier, located in West Antarctica, is a critical area of concern due to its potential to collapse in the coming decades. If this glacier were to melt completely, it could contribute around 65 centimeters 2 feet to global sea levels. This possibility underscores the importance of monitoring the glacier to understand the mechanisms of ice sheet collapse and to prepare for potential sea level rise. The WAIS, which includes the Thwaites Glacier, could also collapse over a longer time frame, potentially raising sea levels by about 4 meters, 13 feet. The stability of the WAIS remains uncertain, with predictions suggesting that significant changes may not become clear until 2100 or later. The likelihood of complete Antarctic ice melting. Despite the alarming potential consequences, the complete melting of all Antarctic ice remains highly unlikely within the next several hundred years. Even under extreme climate scenarios, it would take a prolonged period of sustained warming to melt the entire ice sheet. Current climate models project significant ice loss in Antarctica due to rising temperatures, but they do not predict total melting. Mitigation efforts, including reducing greenhouse gas emissions and enhancing climate resilience, are crucial in preventing the worst-case scenarios of ice melt and associated sea level rise. Addressing the challenges posed by Antarctic ice melt requires long-term strategies focused on sustainable development, environmental conservation, and global cooperation. By understanding the complex interactions between ice sheets, climate, and human activities, we can develop effective policies to mitigate the impacts of climate change and preserve our planet's future. The hypothetical scenario of all Antarctic ice melting presents a stark reminder of the interconnectedness of Earth's systems and the profound impact of climate change. While the complete melting of Antarctica is unlikely in the near future, the potential consequences underscore the importance of proactive measures to address climate change and protect vulnerable ecosystems and communities. As we continue to study Antarctica's ice dynamics and monitor changes in the region, it is essential to integrate scientific knowledge into policy decisions and public awareness. By doing so, we can build resilience against the challenges posed by a warming world and ensure a sustainable future for generations to come. If all the ice in Antarctica were to melt, the environmental consequences would be severe and widespread globally. First, the global sea level would rise by approximately 70 meters, 230 feet, leading to the flooding of numerous coastal cities, erasing many low-lying nations, and displacing billions of people. The chemical composition of the sea would also become a concern, as fresh water from the melting ice would reduce ocean salinity, impacting marine ecosystems and potentially disrupting critical ocean currents that influence climate. Additionally, the disappearance of the ice would trigger isostatic rebound, causing the Antarctic continent to rise due to the loss of ice weight, a process lasting tens of thousands of years and potentially leading to significant geological changes. The temperature effects from the ice melt indicate that global temperatures have risen significantly, surpassing extreme climate change scenarios, making many tropical regions uninhabitable and causing ecological disasters such as crop failures and mass extinctions of various plant and animal species. This scenario underscores the importance of mitigating climate change, protecting sensitive ecosystems, and enhancing adaptation measures to safeguard humanity and biodiversity from potential consequences. What happened if the sun never set? The sun, our closest star, is the cornerstone of life on Earth, providing the energy necessary for ecosystems to thrive and supporting the delicate balance of our planetary climate. However, it also harbors destructive potential. From the health risks posed by its radiation to the long-term climatic changes it could instigate, the sun's influence is profound. What if the sun never set, and Earth was bathed in continuous daylight? This thought experiment explores the scientific ramifications of such a scenario, delving into its impacts on biology, ecology, and human society. Tidal locking is a phenomenon where an astronomical body consistently shows the same face to the object it orbits due to synchronous rotation. The moon is tidally locked to Earth, always presenting the same side to us. While the moon rotates, it does so in perfect harmony with its orbit around Earth, resulting in a day that lasts as long as its orbital period. This synchronization leads to misconceptions about the dark side of the moon, which actually experiences periodic sunlight. In our solar system, several moons exhibit tidal locking. Titan, Saturn's largest moon, is tidally locked to its planet, and Pluto and its largest moon, Charon, are mutually tidally locked, always showing the same face to each other. Mercury, the closest planet to the Sun, is in a 3.2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits around the Sun. Consequently, even on Mercury, the Sun rises and sets, albeit in a very slow and peculiar manner. Exoplanetary research suggests that many planets' inhabitable zones around red and white dwarf stars may also be tidally locked. These planets might host life, but only one hemisphere would receive perpetual daylight, while the other would remain in eternal darkness. This unique condition raises intriguing questions about the potential for life and the environmental adaptations that might arise. Imagining Earth becoming tidally locked to the Sun involves drastic changes in our planet's rotation and orbit. Currently, Earth experiences a 24-hour day-night cycle due to its rotation. This cycle is essential for regulating biological rhythms, climate patterns, and ecological processes. Without this cycle, the consequences would be profound. Human health relies heavily on circadian rhythms, the internal biological clocks that synchronize with the 24-hour day-night cycle. These rhythms regulate sleep, metabolism, hormone production, and other vital functions. Continuous daylight would severely disrupt these rhythms, leading to sleep disorders, cognitive impairments, and a host of other health issues. Studies on long-haul pilots and astronauts reveal the challenges of disrupted circadian rhythms. These individuals often experience fatigue, decreased cognitive function, and other health problems due to irregular light exposure. A world with perpetual daylight would force the entire human population into similar conditions, exacerbating stress and health issues. A 2016 study, published in Current Biology, exposed mice to continuous light for 6 months, resulting in significant stress and symptoms associated with various diseases, including muscle and bone degeneration. Although these effects were reversible once normal light conditions were restored, a permanently sunlit world would make such recovery impossible, leading to chronic health problems. Continuous sunlight would also wreak havoc on Earth's ecosystems. Many species rely on the day-night cycle for hunting, reproduction, and other behaviors. Predators often hunt under the cover of darkness, while prey species use the night for protection. Perpetual daylight would disrupt these dynamics, potentially leading to population declines and even extinctions. Plants, which depend on a balance of sunlight and darkness, would suffer greatly. Photosynthesis, the process by which plants convert light energy into chemical energy, requires periods of darkness to function efficiently. Continuous sunlight would overexpose plants, causing them to overheat, dehydrate, and eventually die. Crops, which are the foundation of human agriculture, would fail, leading to food shortages and economic collapse. Moreover, constant daylight would result in extreme temperature fluctuations. Without the cooling effect of night, temperatures on the sunlit side of Earth would soar, creating desert-like conditions. This would exacerbate water scarcity, increase the frequency of wildfires, and further stress already vulnerable ecosystems. Conversely, the dark side of Earth would plummet into freezing temperatures, making it uninhabitable for most life forms. If Earth were to become tidally locked to the Sun, humans and other species would need to develop radical adaptations to survive. One potential strategy involves migration. Populations could move between the sunlit and dark hemispheres, seeking refuge from extreme conditions. However, this would require unprecedented levels of global cooperation and mobility. Human societies might establish settlements along the Terminator line, the boundary between the light and dark sides. This region would offer relatively moderate conditions, allowing for a semblance of a day-night cycle through controlled movement. Advanced infrastructure, such as climate-controlled cities and artificial habitats, would be essential for survival. Subterranean living could also become a necessity. Underground shelters and cities would provide protection from continuous sunlight, extreme temperatures, and radiation. These habitats would need sophisticated life support systems, including artificial lighting to simulate day-night cycles, hydroponic farms for food production, and advanced medical facilities. Technological solutions might include the construction of vast shading structures to protect large areas from continuous sunlight. These structures could regulate light exposure, temperature, and radiation levels, creating habitable zones on the surface. Such mega-projects would require immense resources and international collaboration. Living in a world of perpetual daylight would have profound psychological and social implications. Continuous exposure to light can lead to sensory overload, affecting mental health and well-being. Increased rates of anxiety, depression, and other mental health disorders would likely emerge as individuals struggle to cope with the lack of darkness. Social structures and cultural practices would need to adapt to new light conditions. Traditional concepts of time, daily routines, and social activities are rooted in the day-night cycle. In a world without night, societies would need to develop new timekeeping systems and cultural norms to maintain order and coherence. Educational systems, work schedules, and leisure activities would undergo significant changes. Without a natural division between day and night, balancing work and rest would become challenging. Ensuring that individuals receive adequate rest and leisure time would be crucial for maintaining productivity and overall well-being. The thought experiment of a never-setting sun extends beyond practical concerns into the realms of theoretical and philosophical inquiry. It challenges our understanding of time, existence, and the nature of life itself. How would continuous daylight affect our perception of time? Would it alter our understanding of life cycles, growth, and decay? Philosophically, the absence of night could lead to a re-evaluation of the human relationship with nature. Night has always been a time for rest, reflection, and introspection. Without it, the pace of life might accelerate, leaving less room for contemplation and spiritual growth. The constant presence of the sun could symbolize unending activity and progress, but also relentless pressure and stress. The possibility of adapting to a never-setting sun also raises questions about human ingenuity and resilience. How far can technology and innovation go in countering the forces of nature? Can humanity thrive in an environment so drastically altered from the one in which it evolved? These questions probe the limits of our adaptability and the ethical considerations of altering natural systems for survival. The scenario of a sun that never sets presents a fascinating and challenging thought experiment, pushing the boundaries of our understanding of biology, ecology, and human society. Ultimately, the thought experiment underscores the importance of the natural cycles that govern our lives. The alternation of day and night is more than a mere convenience. It is a fundamental aspect of the Earth's environment that shapes the rhythms of life. As we continue to explore the mysteries of the cosmos, we are reminded of the intricate connections that sustain our existence and the profound impact of celestial forces on our everyday lives. Kepler 22b, an exoplanet located 635 light-years away, offers the potential for life due to its placement within the habitable zone of a sun-like star. Discovered using the transit method, this distant world is 36 times the mass of Earth, with a radius 2.5 times larger. Despite its proximity to its star, Kepler-22b receives a similar amount of sunlight, resulting in a temperate climate comparable to Earth's spring. However, challenges arise from its potential tilt, causing extreme seasonal variations. Recent studies suggest the presence of a deep ocean that could moderate temperatures, offering hope for habitability. Imagine being seated on Earth, contemplating the vastness of space when your mind is drawn to a distant celestial body, Kepler-22b. Located a staggering 635 light-years away, this exoplanet has captivated astronomers and enthusiasts alike since its discovery. What sets Kepler-22b apart is its unique position within the habitable zone of a sun-like star, Kepler-22. This Goldilocks zone is the sweet spot around a star where conditions are just right for liquid water to exist on a planet's surface, a fundamental prerequisite for life as we know it. Kepler-22b's existence hints at the tantalizing possibility of life beyond our solar system, sparking questions that have long intrigued humanity. How long would it take us to reach such a distant world? What secrets does it hold about its climate and environment? And why would venturing to Kepler-22b require extensive preparation? To uncover the mysteries of Kepler-22b, scientists have employed ingenious methods, such as the transit method, to detect exoplanets hidden within the glare of their parent stars. By observing the slight dimming of starlight as a planet passes in front of its host star, researchers can infer crucial details about the planet's size, orbit, and even its potential habitability. What we've learned about Kepler-22b is both awe-inspiring and humbling. With a mass 36 times that of Earth and a radius 2.5 times larger, this distant world presents a striking contrast to our own familiar planet. Yet, despite its larger size and closer proximity to its star, 15% closer than Earth is to the Sun, Kepler-22b enjoys a remarkably similar amount of sunlight, fostering a climate that could be akin to a perpetual spring day on Earth. However, amidst the excitement of the discovery, there are sobering considerations. Models suggest that Kepler-22b may be tilted on its axis, much like our solar system's ice giant, Uranus. This axial tilt could result in extreme seasonal variations, with prolonged periods of darkness or sunlight at the poles. Such conditions pose significant challenges for potential human colonization, highlighting the harsh realities of space exploration. But hope springs eternal in the vast expanse of our galaxy. Recent studies suggest that Kepler-22b may boast a vast ocean, up to 50 meters deep, covering its surface. This oceanic feature could serve as a natural buffer against temperature extremes, acting as a stabilizing force for the planet's climate. Like a colossal thermostat, the ocean would store heat during warmer periods and release it during colder times, ensuring a relatively hospitable environment for any potential inhabitants. Kepler-22b stands as a beacon of possibility in the cosmic ocean, inviting humanity to ponder its place in the universe and the boundless wonders that await exploration. While challenges abound, The allure of discovering new worlds and unlocking the secrets of distant planets continues to drive our curiosity and imagination, propelling us ever closer to the stars. A distant exoplanet teeming with uncertainties and possibilities. At a staggering distance of 635 light-years away, Kepler-22b beckons humanity with its potential as the first discovered planet within the habitable zone of a sun-like star. Embarking on this journey presents a myriad of challenges, not least of which is the sheer distance involved. Even traveling at the speed of light, a journey to Kepler-22b would span 635 years, far beyond the natural lifespan of any human. To bridge this astronomical gap, innovative solutions such as cryogenic sleep chambers offer a glimpse into the realm of possibility. By inducing a state of hibernation, astronauts could endure the passage of time, preserved within these advanced pods while en route to their distant destination. However, cryosleep is not without its risks and complications. The physiological effects of extended periods in stasis are not fully understood, and the potential for unforeseen consequences looms large. Moreover, the technology required to sustain life over such vast distances must be foolproof, capable of withstanding the rigors of space travel and ensuring the safe return of its occupants. Beyond the logistical challenges, the mysteries of Kepler-22b only deepen upon closer examination. Gravity, a fundamental force governing the dynamics of celestial bodies, remains an enigma. The gravitational pull on Kepler-22b could vary dramatically from that of Earth, exerting profound effects on the human body and necessitating extensive adaptation measures. Strength training regimens designed to counteract the increased gravitational force become imperative, ensuring that settlers are equipped to withstand the unfamiliar conditions awaiting them on the exoplanet's surface. Furthermore, the composition and atmosphere of Kepler-22b remain shrouded in uncertainty, adding another layer of complexity to the equation. Is it a rocky planet akin to Earth, or does it harbor a dense, gaseous atmosphere reminiscent of Neptune? The answer could spell the difference between a habitable oasis and a barren wasteland, dictating the survival prospects of future colonists. Navigating these uncertainties requires a blend of scientific ingenuity and unwavering determination. From innovative habitat designs to advanced robotics capable of constructing underground shelters, humanity must leverage its collective expertise to overcome the myriad challenges posed by interstellar travel. Ultimately, the quest for habitable exoplanets serves as a testament to humanity's boundless curiosity and unyielding spirit of exploration, driving us ever forward in our quest to unlock the secrets of the cosmos. The story of Kepler-22b offers many important lessons and perspectives on space exploration and the role of humanity within it. It underscores an awareness of the difficulties and risks of space exploration. While advanced technology may open doors to distant planets, the challenges of transportation, adaptation, and survival on new planets are numerous. This highlights the importance of continued research and technological development to make this vision more feasible. Additionally, Kepler-22b serves as a reminder of the preciousness of Earth and the unique living environment it provides. While the search for new planets may stimulate human curiosity and exploration, it also provides an opportunity to reflect on and appreciate the value of our own planet. Finally, the story of Kepler 22b inspires hope and courage in facing new challenges. Despite the risks and uncertainties, the desire for exploration and discovery remains a powerful motivation to venture further into space and search for extraterrestrial life. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.